Welcome. Thy presentation deals with the uses of quantum computing in healthcare. Knowledge is quantum power. Physicians need to know about the phenomenal currently available computers. They will be using both classical and quantum computers for sundry medical purposes, including prevention, diagnoses, and treatment of diseases. Quantum computing has the ability to store, process, and analyze data at speeds far beyond what classical computers can achieve. It utilizes the principles of quantum mechanics to process information and perform computations. Quantum computing is not a subset of artificial intelligence (AI), but it can enhance machine learning algorithms, which enables AI to tackle more complex problems and larger data sets. What are bits and qubits, or quantum bits? Bits are used in classical computing. A bit can only be 0 or 1. So bits are the basic units of information that can separately be in one of two states, either 0 or 1. Qubits, which is short for quantum bits, are used by quantum computers. Qubits can exist in a state of 0 or 1. But qubits 0 and 1 can be in a superposition of both states simultaneously. And the qubit superposition can be represented anywhere on a sphere. Let us first review some of the properties of classical computers. Classical computers process information sequentially. They can only perform one calculation at a time. They use algorithms which are designed to work with bits and are based on Boolean logic. They are limited by the speed of their processors and the efficiency of their algorithms. They have well-established methods for error correction and handling. They are based on transistors and integrated circuits that can be miniaturized to a certain extent. And they are versatile and can be used for a wide range of applications, from everyday computing tasks to complex simulations. In contrast to classical or regular computers, quantum computers are more advanced. They are based on the following concepts. First, the term quantum, in the context of physics, refers to the smallest possible unit of a physical property, such as energy or light. It's like the building blocks of the universe, dealing with extremely tiny things, much smaller than atoms. Second, quantum computers are a new type of computer that uses the principles of quantum physics to process information. Quantum computers use qubits, which can exist in multiple states at the same time. This allows quantum computers to perform many calculations simultaneously. This makes them potentially much faster than regular computers for certain types of problems. Third, quantum computers use something called algorithms. Quantum algorithms are sets of instructions specifically designed for quantum computers. The algorithms take advantage of the unique properties of qubits to solve problems in ways that are impossible for classical computers. Quantum algorithms are specifically designed to not only harness the power of qubits, but also take advantage of quantum phenomena like superposition, entanglement, and quantum tunneling, which are discussed below. These algorithms can help with things like searching large databases, factoring large numbers, which is important for encryption, and simulating complex chemical reactions. Fourth, quantum computing is the field of study that focuses on the development and use of quantum computers. Quantum computing involves understanding how to manipulate qubits to perform computations, creating new quantum algorithms, and building the hardware and software needed for quantum computers to work. The goal of quantum computing is to harness the power of quantum mechanics to solve problems that are currently too complex or time-consuming for classical computers. So what is quantum superimposition? Quantum superposition is a fancy term for the ability of quantum particles, like electrons or photons, to exist in multiple states, or positions at the same time. Imagine you have a coin that can be both heads and tails at the same time instead of just one or the other. This might sound weird, but it is a real phenomenon at the tiny scale of atoms and subatomic particles. It is like a quantum particle is making up its mind about its state only when it is observed or measured. Quantum superposition allows quantum computers to process and perform numerous calculations simultaneously, resulting in exponential increases in computing processing power for some types of problems. The term quantum entanglement was mentioned earlier. What is that? Quantum entanglement is a phenomenon where two or more quantum particles become interconnected in such a way that the state of one particle instantly influences the state of the other, no matter how far apart they are. It is as if the particles are linked by an invisible thread that allows them to communicate instantly, even if they are light years apart. This connection is created when the particles interact in a specific way, and it means that measuring the state of one particle immediately tells you the state of the other, as if they were sharing information faster than the speed of light. This spooky action at a distance, as Einstein called it, is one of the most fascinating and counterintuitive aspects of quantum mechanics. In other words, quantum entanglement allows qubits to be linked together, entangled, in such a way that the state of one qubit can depend on the state of another, regardless of the distance between them. Entanglement is used to process information in parallel and solve complex problems that classical computers cannot achieve presently. Another term mentioned earlier is quantum tunneling. Let's explain this. Quantum tunneling is a phenomenon where a quantum particle can pass through a barrier that it should not be able to cross according to classical physics. It is as if the particle can magically appear on the other side of a wall without having enough energy to climb over it. This happens because of the wave-like nature of quantum qubit particles. This effect is crucial in many technologies, like the operation of some types of transistors in modern electronics. Stated differently, quantum tunneling is a phenomenon in quantum mechanics, where a particle has the ability to penetrate and pass through a potential barrier that it would not have enough energy to overcome, according to the principles of classical physics. This effect is a direct consequence of the wave-like nature of particles at the quantum level. It is worth remembering that in classical physics, if a particle encounters a potential barrier higher than its kinetic energy, it would be unable to pass through and would be reflected back. However, in quantum mechanics, particles are described by wave functions, which represent the probability of finding the particle in a particular location. Due to the probabilistic nature of quantum mechanics, there is a non-zero probability that a particle can be found on the other side of the barrier, even if it does not have enough energy to surmount it. Quantum computers are more susceptible to errors. Why is that? The first reason is that they require specialized hardware such as superconducting circuits, trapped ions, or quantum dots. And second, the quantum computer hardware must be maintained at extremely low temperatures to prevent quantum states from being disrupted. Keep in mind that quantum computers are not meant to replace classical or regular computers for all tasks. However, they excel in specific areas such as cryptography, optimization problems, and simulations of quantum systems. Well, what are some of the applications of quantum computing in healthcare? First, it is used in genomics and personalized medicine. Quantum computing can significantly accelerate the analysis of large genomic datasets, which can advance genetic research and personalized medicine. As to personalized medicine, quantum computing can help identify genetic markers associated with diseases. This can enable personalized, precise medical treatment plans that are more likely to be effective for individual patients. Second, radiation therapy planning. Quantum computing can optimize the planning of radiation therapy for cancer patients. When radiation quantum therapy is accurately planned, the treatment is precise and effective. Additionally and importantly, the radiation therapy causes minimal damage to adjacent healthy tissue. The third application is drug discovery and design. Quantum computers can simulate the behavior of molecules and chemical reactions at a quantum level. What this means is the scale at which quantum mechanics operates. As mentioned already, this typically involves the behavior of particles at the atomic and subatomic levels. This is crucial for discovery of more effective drugs and treatments tailored to individual patients' genetic makeup. The fourth application involves protein folding. Quantum computers can simulate protein folding much faster than classical computers. This can lead to breakthroughs in biochemistry and medicine. It is essential to understand how proteins are folded, what their structure looks like, and how they function, and importantly, how protein folding relates to diseases. This is also crucial for developing safe and effective treatments for diseases. In 2021, David Julius and Artem Pataputian were the two Nobel Prize winners for their work on protein folding. They were awarded the Nobel Prize in Physiology or Medicine for their discoveries of receptors for temperature and touch. The fifth application is enhancing machine learning and AI. Quantum computing can accelerate machine learning algorithms by analyzing medical images, genetic data, and other health-related information and predicting patient outcomes. Quantum computing identifies patterns in healthcare data that classical computers might miss. Thus, quantum-enhanced machine learning can lead to more accurate and timely diagnoses. The sixth application is performing complex data analysis. Quantum computers can process and analyze large and complex datasets much faster than classical computers. This capability is particularly useful in healthcare diagnostics, where vast amounts of medical data, including genetic information, imaging studies, and patient records, need to be evaluated to make accurate diagnoses and disease risks. The seventh application is big data analysis. Quantum computing can process and analyze large datasets. For example, big data obtained from genomics and electronic health records, as well as other sources, can be processed rapidly and analyzed to identify patterns and biomarkers associated with complex diseases. This enables earlier and more accurate diagnoses and treatments. The eighth application is complex disease modeling. Quantum computing can model complex diseases and biological systems. This helps researchers to understand the underlying mechanisms of diseases and to develop more targeted therapies. The next three applications involve simulations of molecular interactions, molecular dynamics, and biological processes. Quantum computers can simulate the behavior of molecules and their interactions at a quantum level. This is crucial for understanding the molecular basis of diseases, and this can lead to the development of more targeted drugs and personalized treatments for complex diseases. Quantum computing can also enhance molecular dynamics simulations. This is used to study the movement and interactions of atoms and molecules. These simulations can be particularly useful for understanding how diseases progress and how drugs interact with the body at an atomic level. Quantum computers can simulate complex biological processes and molecular interactions at a level of detail that is beyond the reach of classical computing. This can help in understanding diseases at the molecular level and in designing more effective diagnostic tests and treatments. The next three applications involve the capability of quantum computers to optimize predictive models, diagnostic protocols, and treatment plans. Quantum algorithms can optimize the design of predictive models, ensuring that they are as accurate and reliable as possible. This can lead to better decision-making in healthcare and more effective prevention and treatment strategies. Quantum algorithms can optimize complex logistical problems such as scheduling, resource allocation, and supply chain management in healthcare systems, leading to more efficient operations and better patient care. They can optimize diagnostic protocols and decision-making processes. This ensures that healthcare providers use the most efficient and effective diagnostic methods available. And quantum algorithms can optimize other complex logistical problems, such as treatment scheduling and resource allocation. This ensures that patients with complex diseases receive the most efficient and effective care. The next application in healthcare is cryptography and data security. As healthcare data becomes increasingly digitized, quantum computing can enhance cryptographic methods to ensure the security and privacy of sensitive medical information. And quantum computing can contribute to the development of more secure and reliable diagnostic systems by enhancing error correction mechanisms. A final note is about quantum intuition, and knowledge is quantum power. Quantum inhibition can be explained as follows. Everything is energy. Energy connects everything and carries information. The past, present, and the future all exist simultaneously. Therefore, as energetic human beings, we have access to the past, present, and future at any point in time via energy. It all connects. We should also keep in mind that knowledge is quantum power. This indicates that the power of knowledge, in the context of quantum mechanics, denotes the ability to harness the principles of quantum mechanics to achieve significant advancements and control over the physical world. Quantum computers comprise technologies that exploit quantum properties to perform computations at speeds far beyond those of classical computers. Thank you for listening.